In our previous video, we made a network graph consisting of node and edges. And since this is a hierarchical or org chart, we also have direction for how the information flows. So here we created that org chart. And just a reminder, if you want to work along with us, we're at drstephpowers.github.io/management in Python. And you can find the org chart here. And let's go into our data set. And what we're going to do is we're going to use network X as NX. And what we did in a previous video is we created the org chart using network X. So refer back to that video to create this graph. Once you have created this chart and we call this chart G, then what we can do is we can analyze this chart to look at the level of centrality within our organization. So when we talk about centrality, there are different ways to measure centrality. We can look at the number of contacts that any particular node has, looking for the individual who has the most number of contacts, the most people they interact with. We can look at eigenvector, the amount of influence a node has. And so, of course, the more contacts you have, the more influence you will have. But the eigenvector also looks at how many contacts your contacts have. So, for example, in this particular image, not only does this person in the center have 6 contacts, but notice that everybody else is tied to one of those 6 people. So this is the social media influencer who has the most spread of information. They talk to people and those people talk to other people, and the information has the greatest spread there. The next measure of centrality is closeness. When we look at closeness centrality, we are looking at how many ways a node is connected to other nodes. And so is there ways to get access to other people? So we're looking here, and it's going to relate to betweenness. Betweenness is the other measure of centrality, which looks at how many nodes you have to go through to get to another person. So we look at that distance here, that path, and if you are connected to other people through many different routes, then there will be shorter paths for you. So we'll look at closeness and betweenness. And of course, if you're the social media influencer, or you're the hub, I guess is the way to put it, you're a hub here, then this particular group doesn't talk to that particular group. They have to go through you. So then you have a high level of betweenness if you're that hub that everyone has to go through. All right, so let's take a look at in terms of our org chart. To find the degree of centrality, we're looking at the percentage of nodes that any particular node is connected to, or the percentage of people you interact with. So on our org chart, we do nx.degree_centrality, and G is our graph here. So when we do this, in this particular case, these labels 0 through 7, these are our people, which are CEO, Team A lead, Team B lead, Staff A, Staff B, Staff C, Staff D, Staff E. Because we made this graph on our own, these don't already have labels, unlike the video with the Game of Thrones, where we had a spreadsheet that had the source, the target, and so these were already labeled. So in which case, what we're going to have to do is separate out from this dictionary here the values. So send.values gives us just the degree centrality measures. And then we can create a bar graph here with matplotlib.pyplot as PLT with the names that correspond with numbers 0 through 7. So when we do that, we plt.bar, and then we have our list there of people, and then send.values. And then we can put it on a rotation of 45. We'll check that. If the names don't overlap, we can leave it that way. If you have long-winded names, then do a 90 degree so that it gives them lots of space. So notice in this case, for the degree centrality, it says that Team B lead has the highest degree centrality. So let's take a look at our graph. And it's about the number of nodes you're connected to. So Team A lead is connected to 3 nodes, but Team B is connected to 4. The CEO is connected to 2. So we can see Team B lead has the most contacts. Okay. So Team B lead is going to interact with the most people, is what we're saying here. All right, eigenvector centrality. Which node has the most influence? Now, when we look at eigenvector centrality, we use eigenvector underscore centrality underscore numpy. Now, when we did this with the Game of Thrones example, we just put comma G and did it that way. In this case, we have directionality to the communication based on the directions of the arrows. So if you leave G just as it is, it's going to add the centrality of predecessors. G reverse adds the centrality of successors. And so in this particular case, we want to look at who has the most influence. Because our org chart flows information down in terms of direction, we actually want to go G reverse. So when we do this, what we find, and then we separate out the eigenvalues and then put it on our graph just like before, what we see here is the CEO has the largest eigenvector centrality. And this should make sense because who has the most influence? Let's go back to our graph. The most influence is the CEO. They give direction to team A and B leads who give direction to the staff. If you don't hit G reverse, if you just do G as it is, it'll say the staff has the most influence rather than the CEO. So make sure the information you're getting makes sense. Okay. In terms of betweenness centrality, we're looking at the times a node is part of the shortest path. How many people do you have to go through to communicate in the office? So to find betweenness centrality, we do betweenness underscore centrality, and we do G here. We'll call this bet. Again, we don't have the labels attached here, so we're going to separate out the values and put in the labels into our graph. So same as before, this is just the between values instead of the other ones. And what we see here with betweenness is team B lead has the most betweenness. And if we go back, that's because if you want to contact someone, who do you have to go through? Well, you have to go through team A lead for staff to CEO and staff B to CEO. Well, that's 2 people. But team B lead you have to go through them for both staff C to CEO, CEO to staff D, CEO to staff E. So team B, you have to go through the team B lead more in this organizational chart than anybody else. Okay, and if we were adding more communication lines between, you can have horizontal location lines if there's like the team meetings where all the team leads get together. You could have horizontal lines where staff A and B get together. And so you can increase the level of communication at a horizontal level so that there is shorter paths in terms of communicating. Because if team B lead needs to communicate with staff A, technically they need to go to the CEO and all the way through to the team A lead and down, assuming that information can flow the other direction. All right, so our last one here is the closeness. So that was betweenness. Let's look at the last one, which is closeness. Closeness is the average length of the path to other nodes. How many people do you have to go through to communicate with someone else? So it's going to be similar to the betweenness, but it's also going to consider multiple paths. Whereas the betweenness, how many people we had to go through. Closeness will also consider the number of paths. So when it comes to closeness centrality, if you are looking at inward distance, you're going to do G as is. If it is outward distance, you're going to do G reverse. So let's take a look at this closeness here, okay, with G as is. And we are going to separate out the values and then plot the graph. So what we see in this way when it's just the inward distance is in terms of closeness. Here we have the CEO that has the least amount of closeness. So if we think about a highly centralized organization, there is low closeness. People are not particularly close to each other. The CEO dictates down to the other people who dictate down to those. So highly centralized organizations have very low closeness centrality. Okay. And when we look at our closeness centrality, we're looking at in terms of how many ways a node is connected to another node. So in a setup like this one here, the one with the best closeness is this one here because it only has the shortest paths here, or only ones to a lot of people, as opposed to the other ones where it is much further away. So we need to consider with our closeness, who has the best closeness and whether it is more appropriate to do an inward distance or an outward distance. In terms of closeness, we would look at these individuals. They don't actually have a lot of closeness in the way that it's a highly structured hierarchical site. So what we would do is change this not from G, but we would want to do G reverse, similar to what we did up here, where it's G dot reverse. So we want to put it like this. Let's go back. You can see when we switch it to G reverse, what it does with our graph is that it then flips it. And so what you have is those who are closest are going to be the CEO and the team leads. And that's because that's the way it should be for this structure. It should be the reverse. We are going outwards as we're going from our node out. And what we see here is that staff A, B, and C, they are not close with other people, right? They get dictated to, they don't communicate with anyone else. Our CEO is the one who is communicating with others, and team A lead and B lead are the conduits between the CEO and the staff, so they're going to have a much higher level in terms of being closer to others in the organization. Whereas in a highly structured hierarchical model, all of the peons at the bottom here are not close to anyone. They don't get to interact with the rest of the organization. So make sure when you are doing this, particularly the closeness one, should it be G or G reverse, depending on the flow of information. And so that directionality matters and which one we choose matters. Okay. And then the other one where you have to be cognizant of that G or G reverse is with the eigenvector centrality. Again, coming back to directionality of flow of information. Okay, so now that we've done that, try with the other model. So in our previous video, we created an organizational chart that looked like this here. Maybe you have the CEO dictating to board 1 and board 2, or maybe you have it flowing the other direction. Can you create those measures of centrality for this particular org chart to see who has the most influence? Try it with the arrows going this way for board 1 and board 2. Flip the arrows, right? So let's switch these 2, 0, 2, 1 here to change this. So I'll just flip these here. 2, 0 and 2, 1. So if we change those, then the CEO is now dictating to the board. Does that change who is the most central, the most influential, who has the most contacts? Does that change the level of closeness and betweenness within the organization?